Hello everyone, welcome to Go Score. We are the fastest growing edtech in GCC. And our main aim is to provide the quality education for all. Welcome to another marvelous, wonderful session of chemistry. And here we are with the revision session of the chemistry. You might be already knowing about that, right? And we are going to deal with the second chapter today, that is acids, bases and salts. Okay, are you guys ready for that? In the previous session, we discussed about the first chapter, right? We have enough knowledge about the first chapter now. Now let's go ahead with the second chapter, which will be having more weightage than the first chapter, okay? So we have to concentrate more on this chapter as well than the first one, okay? So we will gradually scale up the things and we'll go to the third and the fourth chapter as well, okay? For that, you have to just wait, okay? So without wasting any time, I think let's move ahead with the questions because you might be already waiting for the questions to be discussed, right? So we will go with the questions and here we go. And as I have already informed you about the interactive sessions, we are like doing an interactive session. I don't want to do this one-way talking here. So I want an interactive session. I want a response from you guys. If you are there, be active in the live comment session. Okay, so be active and I want to know the answers. Okay, I want to know the answers from everyone. Okay, shall we go with them? All right, here we go with the first question. And before getting into the question, this is your chapter, acid, bases and salts, and tada, the first question. Okay, have a look into the question and we will solve it out together. Okay, we'll solve it out together. All right, we'll solve together so that you have to participate. Here we go with the first question. With the help of an example, explain what happens when a base reacts with a non-metallic oxide. What do you infer about the nature of the non-metal oxide? Since you have completed a set of revision of all the chapters, you might be already knowing an idea about what's there in the chapter, how do you learn and everything, right? So you must be knowing these concepts already. Now it's the time to answer the things. Okay, it's the time to answer the things. So here we go. Okay, so with the help of an example, what happens when a base reacts with a non-metallic oxide? So here we go with the base reacts with a non-metal oxide. Non-metallic oxides. Okay, definitely we are gonna get the salt and the water. Okay, we will get the salt and the water. What is the reason for that? What is the reason that we are getting salt and water when we mix a base with a non-metallic oxide? The answer is really simple. The nature of the non-metallic oxide. The nature of the non-metallic oxide is acidic. So the non-metallic oxides are acidic in nature. Acidic in nature. We know that when the base reacts with an acid, the product that we can expect is your salt and the water. So acid and the base together, salt and the water. So from here itself, we can answer the second question that they have given over there. What do you infer about the nature of the non-metal oxide? And it is acidic in nature. Got the answer? Now we have to explain it with the help of an example. Time to get into the example. We'll be taking base, the most common one. Let's take it as NaOH. Okay, we'll take NaOH as the base and non-metal oxide. Let it be carbon dioxide. Okay, so carbon dioxide is a non-metallic oxide, correct? It's a non-metallic oxide where the carbon is a non-metal. So non-metallic oxide reacts with a base. As I have already informed, the product will be salt and water. If you're confused with the salt which is formed, write down the water first and write down the remaining thing. Okay, so we'll be having, excluding the water, we'll be having the sodium and the carbon dioxide. So definitely the product will be sodium carbonate itself. The formula for the sodium carbonate is Na2CO3. Na2CO3 is the sodium carbonate. The most important thing is to balance the chemical equation. So without writing the balanced chemical equation, you cannot get a full marks for the question. Okay, so make sure that you balance the equations first. Okay, now here we have 2 sodium atoms, but here we have only 1. So make it 2 by multiplying the compound by 2. Now coming into the hydrogen, it's balanced. And the oxygen, it's again balanced. So this is your balanced chemical equation, and that is the example that you can give. That's the example that you can give where a base reacts with a non-metallic oxide, and this non-metallic oxide can act as an acid. So always remember this thing, that your non-metallic oxides are acidic in nature and the metallic oxides are basic in nature. That's an important question that they have repeatedly asking in all the question paper. Okay, so metallic oxides are basic and the non-metallic oxides are acidic in nature. I hope the first question is clear for everyone in the class. Is it? Okay, is everything clear for you? Is everything clear? All right, I hope everything is clear for you guys, and let's move ahead with the second question. What is observed when carbon dioxide gas is passed through lime water? To attempt this question, the first thing that you should know is, what do you mean by lime water? Is the lime water that we are drinking in our homes and the restaurants? Is it that lime water? No, it's lemonade. Okay, it's lime juice. Lime juice and lime water is entirely different. Don't get confused. Okay, so you are in the 10th grade. You must be already knowing the difference between the lime juice and the lime water, right? So what is lime water now? What is lime water now? Before that, just tell me what happens if the carbon dioxide is passed through the lime water. What do we get if the carbon dioxide is passed through lime water? The lime water turns, what happens to the lime water? The lime water turns milky, correct? It will turn into a milky white color, which is really good to say. Okay, so it will turn into a milky color. What is the reason for that? Why is it turning into a milky color? We know that the lime water is really a clear liquid, and when we pass the carbon dioxide through that, it will turn into a milky precipitate due to the formation of what? Due to the formation of insoluble calcium carbonate. Okay, insoluble calcium carbonate will be formed, which is insoluble in the water. That's exactly why we are getting a white precipitate, which is the result, which is the cause for the milkiness of lime water. Now time to get into the equation. Let me change the color of the pen first. Now the carbon dioxide reacting with the lime water. Now the question again, what is the formula for the lime water? Lime water is nothing but your slaked lime itself. What is slaked lime? It's the calcium hydroxide, that is CaOH twice. Okay, so lime water is nothing but the slaked lime, and the formula for that can be given as calcium hydroxide, that is CaOH twice. Now, when we mix these two together, definitely we are going to get an insoluble calcium carbonate, that is CaCO3, which is solid in state and which is a white precipitate. Okay, which is a white precipitate. And writing byproducts is again an important task that you have to be followed. The product will be water. Product is the water. Water is a product that we can expect here. Okay, and check the balancing thing. It's already balanced. Okay, so the milkiness is due to the presence of the white precipitate formed when the carbon dioxide is passed through the lime water. That will give you the answer for the first question. Coming into the second question. For a long duration, okay, so we are passing the carbon dioxide for a short duration, so that we will get the milky white precipitate. Now, what if we pass the carbon dioxide for a long duration? We are going to pass it for the long duration. What is the inference that we can go over here? This is for the first one. And coming into the second one, we already have calcium carbonate and the water when we passed a limited amount of carbon dioxide through the calcium carbonate. Okay, I'm sorry, calcium hydroxide. Now, if we pass it for a long time, we already have the calcium carbonate and water in the test tube. Okay, and we are passing the carbon dioxide again for a long time. Okay, so these are the reactants that will be right in the test tube. Okay, so when they react together, we will get a substance called as calcium hydrogen carbonate, that is CaHCO3 twice. Calcium hydrogen carbonate which will be soluble in the, okay, soluble in water. Okay, it is soluble in the water, whereas the calcium carbonate is insoluble in the water. That you have to mark it. Okay, so calcium carbonate is insoluble in the water, whereas calcium hydrogen carbonate is soluble in the water. Hence, the milky white precipitate disappears. The milkiness disappears. Okay, so that's your second answer. So in the first one, the lime water turns milky. In the second one, the milkiness disappears due to the formation of the soluble calcium hydrogen carbonate or calcium bicarbonate. Okay, cool. Is that clear? Any doubts so far? Nothing, right? Is there any doubts so far? So can we get into the third question then? If you are ready, we can go ahead with the third question. Shall we? Okay, here we go with the third one. Do you read out or do you want me to read out the question for you? Okay, definitely I will. 2 ml of sodium hydroxide, that's an NaOH solution, is added to a few pieces of granulated zinc metal taken in a test tube. Okay, we have took a test tube and in which we have the granulated zinc. Alright. Let me read out the question again. So we have the test tube in which we have the zinc granules, and to that test tube I'm going to add the NaOH. Okay. Now when the contents are warmed, a gas evolves which is bubbled through the salt solution before testing. I hope you remember the diagram of this reaction. That is really important. You should know how to draw the diagrams because it's an important part. And in the exam, they might be asking you to label the part or directly asking you to write the diagram, explain it with the help of the diagram. So you should know how to draw the diagram first. Okay. Now, here we go with the next one. Write the equation of the chemical reactions involved and the test to detect the gas. Okay, so for that, we should know what kind of gas is formed during this reaction. For that, we have to write down the reaction first. Okay, so that is nothing but you have the zinc granules reacting with the sodium hydroxide, that is your NaOH. What do we get if zinc reacts with NaOH? What are the products that we can get when the NaOH react with the zinc? Definitely, you guessed it correct. That's your sodium zincate. The sodium zincate. What's the formula for the sodium zincate? Na2Zn O2 is the equation for the sodium zincate. Definitely, we will get the hydrogen gas as well. It's the hydrogen gas which will be evolving from the test tube. Okay, so hydrogen gas is the gas which will be formed when zinc reacts with NaOH. As I told you, something is missing over here. That is the balanced chemical equation. Balancing is another important task as I have already informed. 2 sodium, so 2 sodium. Is it balanced? No. Definitely it does. Okay, so hydrogen is the gas which is formed during this reaction, and the name for that is sodium zincate. Okay, don't get confused. Sodium zincate. Okay, sodium zincate, which is a really important reaction that you must study. Okay, without learning all these basic reactions, you cannot attend all these kind of questions. Okay, these are kind of tricky questions, but you should understand the concepts and learn. Okay, don't buy hard the things always. And you know that you might be having a lot of reactions in all the chapters, like including all the reactions. It will be around 50 or 50 above. So make sure that you write down the reactions and learn, or else there's a high possibility that you forget the equations. Definitely you will. So continuous practice is the thing that you can do over this, or else you'll be really exhausted. Oh, how many equations that we have, but write and practice. Write and practice is the major important thing that we can do. Okay. So coming into this, they're asking and the test to detect the gas. What is the test that we can do? How do we prove it is a hydrogen gas? If the gas coming out from the test tube, it cannot shout out like I am the hydrogen gas. Cannot, right? So we have to make sure that it is the hydrogen gas produced during the reaction. For that we can conduct a test. What is that test? What is the test that we can conduct to detect the presence of the hydrogen gas? Definitely by using the candle, right? Let's light up a candle or the matchstick. Bring the candle or the matchstick towards the mouth of the test tube. If it is burning with the pop sound, okay, I don't know how to make the pop sound, you might be expert in making the pop sound, right? So if it is making a pop sound, we can understand that that is your hydrogen gas, okay? So if it is burning with the pop sound, that is the hydrogen gas, okay? So that's the test to detect the hydrogen gas. Do you want me to explain that again? Do you want me to? It's nothing. Okay, bring a lighted candle or the matchstick towards the mouth of the test tube. If it is burned with the pop sound, that is the hydrogen gas. All right. The gas which will be evolved when the same metal react with a dilute solution of strong acid. The same metal, that is your zinc. Okay, so we have to write what happens if the zinc reacts with a strong acid. What is the acid that we have to take? Let it be HCl. That's the most common strong acid, right? So let's take HCl. Okay, that's my hydrogen. Don't get confused. Many of my students like, what kind of H is that, ma'am? Still, like I'm happy with my H, so that's an HCl. Okay, zinc going with the HCl, so that we will get definitely that is the right answer with the same thing. Okay, it's the same thing, salt and the hydrogen gas. Okay, so we'll get the salt and the hydrogen gas, that's nothing but your ZnCl2 and the hydrogen gas, which will be evolving from the test tube, okay, or whichever container that you are like that the reaction is taking place. Now coming into this balancing, okay, 2 chlorine, 3 chlorine and 2 hydrogen atom, it's well balanced. Okay, so this is the salt that we will get when the zinc or any metal react with an acid and the base. Okay, so the product or the gas formed will be the hydrogen gas itself, none other than your hydrogen gas. Okay, cool. Any doubts so far? Not able to say anyone in the comment box. Hello guys, are you guys still there listening to the class? Not getting any response? Are you learning something new? Or just bored with the classes and you guys are in the doorstep of your board exam, right? So you should get warmed up and start studying. Okay, so this is your final moments that you can study. After the exam, you cannot blame yourself that, oh, I could have used this time for studying. You cannot, okay? You cannot regret on a time. So study this right now itself, okay? So let's go ahead with the next question then. Sodium hydrogen carbonate is a basic salt. Sodium hydrogen carbonate is a basic salt. Justify the statement. How is it converted into the washing soda? Okay, that's an important question again. Here we go. NaHCO3 is a basic salt. How do you prove that? Okay, we are studying the science, right? We don't just blindly believe on the theoretical concepts. We want the experimental proof for everything, correct? So you have to prove that it is a base. Okay, we cannot, if someone is coming like, it's a base, you cannot blindly trust that it's a base. For that, you should have a proof behind that. Okay, how do you prove that now? Definitely, sodium hydrogen carbonate, what is the formula that we can write? Sodium, hydrogen, and the carbonate. Sodium hydrogen carbonate. Sodium hydrogen carbonate is a salt. Okay, we know that salt can be formed by using an acid and the base. Okay, which is the acid which is the acid behind the salt? Which is the acid? Definitely we can learn that it is a NaOH. Definitely, that's correct. It's NaOH. Okay. Now we want an acid. We want an acid. Like apart from NaOH, we need one more thing. That's an acid. That is H2CO3. What is H2CO3? What's the common name that you can give for H2CO3? Have you heard about H2CO3 before? Definitely, you guys were correct. That's a carbonic acid. Carbonic acid. Okay, when we mix these two together, we will get NaHCO3. along with water. Okay, salt and the water. Now coming into the NaOH, we already know that it is a strong base. NaOH is a strong base, whereas our carbonic acid is your weak acid. Carbonic acid is a weak acid, NaOH is a strong base. The salt formed will be what? Definitely the salt formed will be basic in nature. This is the basic concept that you should understand. Okay, when a strong base reacts with a weak base, okay, when a strong base reacts with a weak acid, the salt that we will get will be basic. Okay, it will be a base. The salt that we will get is a base. Now, let's do the vice versa. If we take a weak base and the strong acid, the salt that you will be getting will be acidic in nature. Okay, it will be acidic in nature. If we take a strong base and a strong acid, the salt will be commended. Okay, so commended. I'm waiting for that. Okay, so that's the question that you have to put in the comment box. Okay, now coming into our question, how is it converted into the washing soda? We proved that NaHCO3 is a basic because NaOH is strong base and H2CO3 is a weak base. And we know that strong base and a weak acid, salt formed will be basic in nature. Coming into the second question, how is it converted into the washing soda? How can we convert the sodium hydrogen carbonate into washing soda? That's again an important task. Okay, shall I erase this? All right, 3, 2, 1, here we go. Now, for that, you should know the formula for the washing soda. Can anyone let me know the formula for the washing soda? What's the formula that you can give for the washing soda? Definitely the washing soda is nothing but your Na2CO3 10H2O. Okay, this is the formula that you can give for the washing soda. Now, from NaHCO3, you have to get the Na2CO3 10H2O. For that, we have to do a couple of reactions in which the first step is nothing but your thermal decomposition. Thermal decomposition of NaHCO3 sodium bicarbonate. Okay, so we are going to decompose the sodium bicarbonate, so that we'll write down the equation for that. I'm changing the color of the pen. Okay, let me this. So that NaHCO3, when I heat this, that's the thermal decomposition, right? What is the decomposition reaction? Where a reactant is breaking down into a 2 or more product with the help of the heat energy. That's what you call as a thermal decomposition. Now, NaHCO3 can be break down into Na2CO3 plus carbon dioxide and water. Okay, so we have to balance it. Let's put a 2 over here. It's a well-balanced chemical equation. Okay, Na2CO3, carbon dioxide and water, and carbon dioxide produced right over here will be in the gaseous state. Okay, so mention the states, which is again a really important part itself. Okay, so thermal decomposition of NaHCO3, we will get Na2CO3. What do you mean by Na2CO3? It is your sodium carbonate. And coming into your second step, what is the second step that you have to do? Second step is nothing but the recrystallization. Exactly, that's correct. Okay, it's the recrystallization. It is the recrystallization of Na2CO3. Okay, the product that we want is Na2CO3 10H2O. Now in our hand we have Na2CO3. So in order to get the 10H2O, we have to add the water. That's it, right? That's what I mean by recrystallization, adding water into that. So we have, let me change the color again. So Na2CO3, into which I'm going to add 10 water molecules. Okay, I'm going to add 10 water molecules, which will be resulting in the washing soda. That is your Na2CO3 dot 10H2O. Can anyone tell me what do you mean by this dot 10H2O? Exactly, that's your water of crystallization. For the washing soda, the water of crystallization is 10. Okay, it is the number of water molecule present in a unit mass of substance. So that is the 10. 10 is the right answer. Okay, 10 is the water of crystallization for the washing soda. Okay, cool. Is there any doubt on this question? So how is it converted to washing soda? The first step is the thermal decomposition. Second step is the recrystallization. So that we will get the washing soda. This is exactly what you call as the washing soda. Okay. All right. Now let's go ahead with this next question. Okay. If you're okay with this, we are moving on, and make sure that you write down the question along with the answer. For that, pause the video and write it down along with the answer. So when you're going like a day before the exam, you can just turn the pages and revise the thing. It will be helpful for you. Okay. You're not doing it for your parents, not for your teachers, not for everyone, but for yourself. Okay. So do everything for yourself. Okay. Now let's go ahead with the next one. Write the chemical formula of the bleaching powder. How is bleaching powder prepared? And for what purpose is it used in drinking water? What is the chemical formula for the bleaching powder? Okay, you might have already heard a lot about the bleaching powder, right? Bleaching powder. Yes, come on, go ahead. What is the chemical formula? Chemical formula, we are studying the chemistry, right? So definitely, what is the chemical formula that you can give for the bleaching powder? Definitely, it does matter. Okay, so bleaching powder. If you write the formula, you can easily give the name to that compound. Okay, so what is the formula that you can give for the bleaching powder? It is the calcium, oxygen, and the chloride. Okay, CaOCl2. That's the bleaching powder. Now, easily you can name it, right? Calcium, oxychloride. It is calcium, oxychloride. Okay, it is a calcium oxychloride, or it got another name, that is your calcium hypochlorite. Okay, calcium hypochlorite or the calcium oxychloride is the chemical name that you can give for the bleaching powder. Okay, so if anyone is asking for the bleaching powder, you have to be like, calcium, give me some calcium oxychloride, okay, or calcium hypochlorite, okay. Let them know that we are studying chemistry, okay. So that's a calcium hypochlorite. Now, the next question is, how is it bleaching powder prepared? How can we prepare this bleaching powder? That's again the next question. Can anyone let me know the answer? How do we prepare the bleaching powder? Okay, it's super easy thing. The calcium oxychloride can be prepared when we treat the chlorine with our slaked lime. Chlorine with the slaked lime will be giving you the bleaching powder. Okay, so chlorine is Cl2, and we know that slaked lime is a calcium hydroxide, that is your CaOH twice. Calcium hydroxide. Okay, to the calcium hydroxide, I am passing the chlorine gas so that what do we get? What do we get? Calcium hydroxide and the chlorine together. What are we preparing? We are preparing the bleaching powder. So the product will be bleaching powder itself. So bleaching powder is nothing but calcium oxychloride. Calcium oxychloride along with what? Along with what? What is remaining in the reactant side? It's a water. 2 hydrogen and 1 oxygen is left, right? So definitely you can write water right over here. Okay, so calcium oxychloride or the calcium hypochlorite can be prepared when the chlorine gas is passed through your slaked lime. Okay, good to go. Good to go. Any doubts in this? Now, what purpose is it used in the drinking water? We are disinfecting the water by using the bleaching powder, right? Definitely the use is disinfection, okay? So we can disinfect the drinking water because it has to be pure, right? We have to make sure that all the germs are killed, okay? So are we murderers? Yes, we are murdering the germs, okay? So in order to kill the germs, we are disinfecting. We are disinfecting the drinking water by using the bleaching powder, okay? By using, what's the use use of the bleaching powder? To disinfect the water, to kill all the germs present in the drinking water so that it will be really safe for us to drink. Okay, so health is really important, right? So we have to disinfect the water first before drinking it. Okay, so bleaching powder is used for that, and this reaction is quite important. Okay, all right. Okay, now any doubts in this question? Any doubts so far? If not, we'll go ahead with the next question. Okay, shall we? Here we go. During electrolysis of brine, a gas G is liberated at anode. When this gas G is passed through the Slaker line, a compound C is formed, which is used for disinfecting drinking water. I just told the answer right now in the first question, right? Now you might be already knowing this. I'll give you just few seconds to solve it out and let me know the answer. Okay, I'll give you a few seconds to solve it out. Just let me know what is G and C first of all. You might be already knowing that, right? Because we discussed it right now. During electrolysis of brine, what is brine? That's a big question. Ma'am, I never heard about brine. I know brain, but I don't know brine. So what is brine? What is brine? Definitely there is NaCl in water. NaCl in the water, sodium chloride or the salt in the water is brine. Okay, so we'll write the equation first, okay? NaCl in water. NaCl in water is called as brine, okay? So when we do it and electrolysis, okay? When we do the electrolysis right over here, electrolysis, okay? Electrolysis, what is electrolysis? What is electrolysis? It's just a decomposition reaction itself. It's just a decomposition reaction itself by using the electricity, okay? By using the electricity, okay? Now what happens is nothing but definitely we are gonna get NaOH, that's your caustic soda or sodium hydroxide, along with the chlorine gas and the hydrogen gas, okay? Both of them are gases which can liberate. But the question is, who is liberating at anode? Who is liberating at cathode? That's again an important question. Okay, who is liberating at anode and the cathode? That you must remember. There's no other way of this that you have to remember. Okay, so we know that chlorine and the hydrogen will be produced. And remember that the chlorine will be deposited. The chlorine will be deposited at anode. Okay, chlorine will be deposited at anode and the hydrogen will be deposited at cathode. Okay, anode it is chlorine and cathode it is a hydrogen. Just think it in the opposite way, okay? So chlorine, right, cannot be cathode, C and the C. So that comes in the opposite way, okay? So just remember by using any codes or something that can keep this in your memory for a while. Okay, so study with some codes, okay? So that's how I remember. The chlorine, just the opposite cathode. So it will be liberating from the anode, okay? So chlorine will be liberated at anode and hydrogen will be liberated at the cathode. And in the question, it's clearly mentioned that it is the gas which is liberated at anode. So from this itself, it is understood that they are talking about the chlorine. So the gas G is nothing but your chlorine. Okay, so it's your chlorine. Write the formula of the G. What is the formula of the G? It is Cl2. It's Cl2 gas. Okay, it's Cl2. That's the formula for the G. Okay, now coming into this, when this gas G is passed through Slaker line, when this gas, that's your chlorine, passed through the Slaker line. What is Slaker line again? What is Slaker lime, guys? What is Slaker lime? Definitely calcium hydroxide, CaOH2. And the product that we will get is bleaching powder. That's a calcium oxychloride. Calcium oxychloride or calcium hypochlorite. Okay, along with water. Now, this is the one which we'll be using or calling as the bleaching powder and use it to disinfect the drinking water, okay? And the compound C is formed, which is used to disinfect the water. So, compound C, I'm writing right over here, okay? Compound C is nothing but your bleaching powder. Okay, bleaching powder, and we have to give the formula as well. So remember, it is CaOCl2. It is the calcium oxychloride. It is the calcium oxychloride. Okay. Write the formula of G and C, which we have already wrote. State the chemical equations involved. So this is the first chemical equation where the brine is undergoing electrolysis to form the gas which is liberated at anode. We got the first chemical equation where this gas is reacting with the calcium hydroxide. That will be your second equation. That's the second chemical equation involved. Okay. Now, what is common name of compound C? Compound C is your bleaching powder, okay, and the chemical name that you can give for that is your calcium hypochlorite or the calcium oxychloride, okay. Now, give its chemical name. We already gave it, right? That's it. Okay, that's it. That's about the question. If you write this much, 3 marks. 3 marks is in your pocket, guys. Okay, how easy the questions are. Don't get panicked, like looking into the long question. The answer is really simple, okay. So if you're not understanding the question, read it twice or thrice until you understand the question, okay? Don't write any wrong answers. There's a high chance of losing marks, okay? Don't do any such things, okay? So read the question properly and give the direct answers, okay? And don't elaborate your answer for just a 3-mark question. Don't write like 10 mark essay, don't. Okay, they're asking for the chemical equation, write down the chemical equation. If they're asking for the formula, write down the formula. That's enough. That's more than enough. Okay, don't write an essay behind that and don't waste the time. Time is really important. Okay, now getting into the next question. A white powder is added while baking cakes to make it soft and spongy. Okay, you might have already cooking, like you are the chefs, right? You might have already like tried cooking something, the cake, okay, in the corona period and everything, like that was viral. Baking cakes was really viral on those times, so you might be knowing how to bake a cake, okay. So in baking cake, you must be adding like one white chips powdery thing, right? What is that thing? Definitely, that's your baking powder, correct? So the answer is nothing but your baking powder, okay. Now, baking powder. Name its main ingredients. What are the main ingredients for your baking powder? What is this baking powder consisting of? Which is again a super easy thing. Baking powder is consisting of the baking soda. Okay, it's consisting of the baking soda and mild edible. Okay, it will be consisting of a mild edible acids. Okay, mild edible acids such as tartaric acid. I'm sorry for that. Okay, hold on. Let me erase it. Okay, tartaric acid or the citric acid. Okay, so when we mix this baking soda with the mild edible acids like a tartaric acid or the citric acid, definitely we will get the baking powder. Okay, now the question is, explain the function of each ingredient. Okay, why are we using this mild edible acid? Why are we using this baking soda? What is the reason for that? Okay, we know that the cakes will be really good if they have a spongy texture, and correct, it should have a spongy smooth texture, right? That's exactly why we are adding the baking soda. Okay, what this baking soda will do? We know that. What's the formula for the baking soda? First of all, what is the formula that you can give for baking soda? What is baking soda, guys? Definitely that is your NaHCO3. NaHCO3 is your baking soda, correct? NaHCO3 is your baking soda. When we heat this, NaHCO3, when we heat this, it will be undergoing a thermal decomposition. So that we will get Na2CO3 and carbon dioxide. and the water. Okay, here is your secret. Here is your secret. It is due to the carbon dioxide. Okay, due to the evolution of the carbon dioxide gas, it makes the cake is spongy. Okay, so and smooth. This the carbon dioxide is the main reason which is giving a smooth texture to your cakes. Okay, so that's why we are adding the baking soda to make the cake fluffy and spongy. Okay, so it is due to the liberation of the carbon dioxide. Now that's okay, baking soda is done. Now why are we using this mild edible acids? What is the role of the acids here? Definitely we know that baking soda is basic in nature. It's basic in nature, correct? And what is the taste of a base? What's the taste of a base? That you must be already knowing, right? What is the taste of the base? What's the taste of the base? It's bitter, right? Taste of the base. Have you ever touched the baking soda in your tongue? Okay, take a pinch of the baking soda. That you can do it in your home, but don't eat a lot. Okay, don't tell like that Christina ma'am, the ghost coat told me like take a spoon of the baking soda and eat it. No, don't. Okay, don't you ever try it. Take a pinch of the baking soda and just drop it in your tongue. Definitely it will be tasting a bitter. Okay, so we don't want the bitter taste. We don't want this bitter taste in our cake. So what do? Add some mild edible acids. It should be edible, okay? So don't add any other like toxic acids into that. It should be a mild edible acids, okay? Don't add like HCl and HNO3. Okay, so mild edible acids so that it can neutralize the base so that we will not get the bitter taste. That's exactly why we are adding the mild edible acids like tartaric acid or citric acid to remove the bitterness of this baking soda, okay? Who likes the cake with a bitter taste? I don't. Okay, so that is the use of the baking soda and the mild edible acids. Okay, write the chemical reaction taking place when the powder is heated during baking. During baking, NaCO3 undergo thermal decomposition to form sodium carbonate and the carbon dioxide, which makes the cakes fluffy and spongy. Okay, that's a perfect answer that you can give for the question. Okay, we'll go. Next question. The pH of salt used to make tasty and crispy pakoras is 9. Identify the salt and write the chemical equation for its formation. Let's list its 2 uses. Okay, so you have to give the uses as well. Now, how do you write it? Go ahead. So, which is a salt that you will be using to make the pakoras? You might have tried it to make the pakoras, right? It should be really crispy. Okay, it should be crispy. How do you make it? Definitely, you will be adding your secret ingredient. That is nothing but your baking soda again. Baking soda will be a super ingredient that you'll be using in the pakoras because it makes it crispy, right? So baking soda. What's the formula for the baking soda? Definitely you guessed it correct. It is NaHCO3. Okay. So that is your baking soda, not the powder. Baking powder is the one which you'll be using in the cake to make it fluffy. Okay. And it will be having a mild edible acids as well. Coming into this will be, you can add the row baking soda itself. Okay. That's your NaHCO3. And since it's a base, definitely the pH is 9. Now, identify the salt, that's the sodium hydrogen carbonate. Write the chemical equation for its formation. You have to write down the formation of NHCO3. They are not asking you to write the decomposition reaction of NHCO3. I have seen a lot of students who's writing the decomposition reaction for this question. No, they are not asking for that. They are asking for the preparation of NHCO3. They are asking the preparation of NHCO3. How do you do that? How do you do that? Definitely, that's correct. So you will be taking the NaCl. You will be taking the NaCl, add carbon dioxide into that, add water into that, also add ammonia NH3 into that. So these are the reactants that you must be using right over here. NaCl, carbon dioxide, water and NH3. And the products that you will get is really simple. You will get 2 products, that is your NH4Cl. NH4Cl, that is your ammonium chloride. Ammonium chloride along with Your NaHCO3, that's your major ingredient, sodium hydrogen carbonate or sodium bicarbonate. Sodium bicarbonate, which will be commonly called as baking. Okay, commonly called as baking soda. Okay, so that's the answer for this question. Is there any doubt? Is there any doubt? And write the chemical equation for the formation. This is the chemical equation for the formation. List two uses. What are the two uses that you can give for the sodium hydrogen carbonate? Definitely in baking. Okay, in baking cakes or like in baking like any snacks, you can use this baking powder or baking soda. And also you can use it as the antacid to cure the acidity. To cure the acidity, it can act as a better cure. So it can act as the antacid. Antacid is the one which we can use to cure the acidity in your stomach. To neutralize the excess of acid produced by your stomach. It's a base, right? So neutralization reaction. You can cure your acidity by using this baking soda. Okay, so these are the important uses that you can mention right over here. Okay, so we have few more questions to discuss, so I'm not here to waste the time, so let's go with the next one. Okay, a white colored powder is used by doctors for supporting fractured bones. Okay, like in a lifetime you might have like fractured your bone, right? And you have the white thing on your hand to like get it corrected. What is that like white thing on your hand? Everyone must be knowing this, right? That's your plaster of Paris, POP. Okay, and they're asking like write the chemical name and formula of the powder. Okay, that's a plaster of Paris and chemistry. I want the chemical name for that. Okay, plaster of Paris, that's a common name. Okay, so for that, first we will write down the equation for that. That's your calcium sulfate. Okay, calcium sulfate half H2O. Okay, so that's your calcium sulfate hemihydrate. Okay, it's a calcium sulfate hemihydrate. Okay, so that's the chemical name that you can give for your plaster of Paris. Calcium sulfate hemihydrate, hemi is the half, right? So that is a half H2O. Now coming into the second question, when this white powder is mixed with the water, a hard solid mass is formed. Okay, what happens if this calcium sulfate hemihydrate is mixed with the water? Let's check it out. Okay, half H2O will mix with how many water molecules? 1.5 water molecules. We'll be taking 1.5 water molecules, so that when they combine together, what do we get? Half is already there. There's another half and 1. So it will be definitely 2H2O. That is your calcium sulfate. 2H2O, commonly called as gypsum. Okay, have you heard about the gypsum? That is a solid substance that you will get when it mixed with the water. Okay, so when we take the plaster of Paris, mix it in the water, you will get a white solid substance called as gypsum. Okay, gypsum. Now, write the balanced chemical equation for the change. Okay, this is your balanced chemical equation. Okay, super easy, right? Yes, it is. Okay, it's a super easy thing. We'll go with the next one. Alright, here we go with the next one. Okay, write the chemical formula of the hydrated copper sulfate and anhydrous copper sulfate. Hydrated copper sulfate and the anhydrated copper sulfate. Okay, we'll be writing the first one, that is a hydrated copper. Hydrated copper sulfate. What is hydrated copper sulfate? Which will be having the water of crystallization. We know that copper sulfate is CuSO4. And since it is hydrated, what is the water of crystallization of copper sulfate? We already know that it is 5H2O. 5 is the water of crystallization of copper sulfate. So copper sulfate 5H2O. 5H2O. Okay. So this is a hydrated copper sulfate which will be having just the color. Definitely it is blue in color. Okay, copper sulfate 5H2 will be having a blue color. Now coming into the anhydrous. anhydrous copper sulfate. Okay, in the case of the anhydrous copper sulfate, definitely you will be having what? What is the formula that you can give? It's anhydrous, so you don't have the water molecules inside that. So it's just the copper sulfate. It's just the copper sulfate. Remember that CuSO4 it's not a liquid substance. Still it's a solid. Okay, still it's a solid. Even though it contains the water molecule, it's just a crystalline substance itself. Okay. Now, copper sulfate is again solid, which will be having a white color. Okay, remember the color of the copper sulfate, the anhydrous copper sulfate and the hydrated. Hydrated will be having the blue color, which will be calling as the blue vitriol. This is a blue vitriol. Okay, now copper sulfate is white in color. So this is the formula for the hydrated copper sulfate and the anhydrous copper sulfate. Now, giving an activity, illustrate how these two are interconvertible. We have to convert copper sulfate into anhydrous copper sulfate and anhydrous copper sulfate into the hydrated copper sulfate. For that, we have to do an experiment. Okay, I told you, right? Drawing diagrams is pretty important. Okay, so look at my drawing skills now. Okay, so we will be having a burner. We have to first place a burner over there. Okay, that's a burner with the fire. Definitely you will be having the fire inside that, right? So my drawing skills are really beautiful, you know. Okay, so let it be a fire. Okay, coming into this, the most important part is drawing the test tube. We should require a test tube. That's a test tube. Okay, and the test tube cannot like fly over there, right? We have to hold it with the tongs. Okay, that's your tongs. Okay, which will be having here hydrated copper sulfate, which is blue in color. Okay, this is your hydrated copper sulfate. Hydrated copper sulfate will be having a blue color. Now time to label the things. It's your burner. Okay, burner, and this is your boiling tube. Okay, this is your boiling tube, and this is nothing but your hydrated copper sulfate crystals. Okay. Okay, this is your copper sulfate crystals. Now what happens if we warm the copper sulfate crystals? Definitely, if we heat it, the water droplets will come and accumulate on the sides of the test tube. Okay, on the sides of the test tube, we can find the water droplets, and the hydrated copper sulfate will turn into an anhydrous copper sulfate. Okay, and the anhydrous copper sulfate will be having a white color. Okay, and it will be having a okay, so it will be having a white color because we know that anhydrous copper sulfate is white in color and the hydrated copper sulfate is blue in color. So take the copper sulfate, take the hydrated copper sulfate. So I'm writing down the equation, okay? Take the hydrated copper sulfate, CuSO4 5H2O. Just heat it. Okay, just heat it so that we will get calcium copper sulfate. Why am I writing the calcium over there? Okay, so copper sulfate and 5 water molecules will be liberated from the test tube. Okay. Now, the second step should be interconvertible, right? How do you convert back into hydrated? That's again important part. So you're going to take this test tube and the water molecule. Okay, a few drops of water must be added into the anhydrate copper sulfate so that we can turn back the things. Okay, so that the copper sulfate. Let's take the anhydrate copper sulfate, add 5 molecules of water into that, so that we will get copper sulfate 5H2. You will get the hydrated copper sulfate. So this is how you will be doing a reaction, okay, the interconversion of the hydrated copper sulfate and the unhydrated copper sulfate. Is everything clear so far? It's all the physical exam, so it's time to wind up the things. So is everything clear? Any doubts? If any doubts, this is the time to clear the doubts. And you can just ask the doubts in the comment section. I am here to solve it out. Okay? I am here to solve it out. Quick. If you have any doubts, just reach out to me. If not, it's the time to say bye-bye, and any further doubts, I will be always available. So drop it in the comment section, okay? So time to say bye-bye. Until then, take care and bye-bye. Stay tuned with the Ghost Core.